Weather changes become hard to adapt, especially in a four-seasons country. It is difficult to tolerate with the freezing cold weather and hot burning summer. Thus, the invention of automatic room temperature sensor will contribute and leave a good impact to society. The main purpose of the system is to regulate and maintain the temperature of a room. It will allow user to set a range of their desired temperature, which later will be compared to measured temperature detected by the sensor. Once the temperature difference being measured, microcontroller will help the system to respond by turning on either heater or fan. Whenever the temperature of a room is detected within the desired temperature, no heater or fan will be turned on. However, the sensor will send signal and notify the system to switch on the heater when it is too cold or switch on the fan when it is too hot.
There are several components used in automatic room temperature controller to make sure it functioning well. Here are the list of components with their functions. Firstly, temperature sensor TMP36 is an electronic device that measures the temperature of its environment and converts the input data into electronic data to signal temperature changes. Second, Arduino Uno R3 is a microcontroller board based on a removable dual inline package DIP, and it has 20 digital input or output pins. Third is breadboard. It allows for easy and quick creation of temporary electronic circuits or to carry out experiments with circuit design. Fourth is NPN transistor BJT. It amplifies the wake signal enter into the base and produce strong amplified signals at the collector end. Fifth is resistor 221 ohm. It is to limit the flow of electric current.
In this system, we use LCD 16x2. It is an electronic display module and has a wide range of applications. A LCD 16x2 means it can display 16 characters per line, and there are 2 such lines. Next, potentiometer. Potentiometer is a simple mechanical device that provides a varying amount of resistance when its shaft is turned. By passing voltage through a potentiometer and into an analog input on our board, it is possible to measure the amount of resistance produced by a potentiometer as an analog value. The next component is diode. Diode only allow electricity to flow in one direction. When you turn the power off to a motor, you get a negative spike of voltage that can damage your Arduino or the transistor. The diode protects against this by shorting out any such reverse current from the motor. The last component is a DC motor, which is the most common type of a motor. It have 2 leads, which is one negative and one positive. If we connect these 2 leads directly to a battery, the motor will rotate. And if we switch the leads, the motor will rotate in the opposite direction.
For this project, 3 circumstances must be inspected, which are normal temperature, lower temperature, and high temperature. This project is carried out to turn on or off the fan and heater depending on the condition. Prior to that, we established the normal temperature to be between 20 and 30 degrees Celsius. Based on this simulation, the temperature sensor has detected the temperature, which is 24.78 degrees Celsius. As a result, the output indicates that the heater and fan will be turned off because the temperature is within the normal range. For this simulation, the display shows that the sensor reading is negative 11.09 degrees Celsius. The heater must be turned on as reading temperature is lower than normal temperature. When the temperature is in range, the heater will be turned off. The temperature reading is higher than 30, which is 43.84 degrees Celsius. Therefore, the fan will activate and will automatically turn off when it reaches the normal temperature.
I will explain about the coding. First, we set the minimum and maximum room temperature, which is 20 and 30. Next, for the system initialization, we set heater pin and fan pin as our output if the desired temperature didn't reach room temperature. First, the LCD will display the desired room temperature range. Next, temperature sensor will sense surrounding temperature and it will display the temperature on LCD. Sensor will compare the surrounding temperature with room temperature which that we had set. First condition, if the surrounding temperature is higher than room temperature, LCD will display temperature is high, turn on fan. When the temperature is in the range of room temperature, LCD will display now temperature is okay, turn off fan. Second condition, when the surrounding temperature is lower than room temperature, LCD will display temperature is low, turn on heater when the temperature is in the range of room temperature. LCD will display now temperature is okay, turn off heater. Last condition, when the surrounding temperature is in range, LCD will display temperature is okay, turn off all.